Hello everyone, this is Shivam Agarwal. We are back with another video on decorators. This is the second video on this topic. In the last video, we saw how the call method works, what is its use, and we saw that the call method is basically used to bypass the function creation to use the object as the function itself. Okay, I created this class, defined the call function to take some arguments and return the product of those two. In this video, we'll discuss how decorators work, what are the use of decorators, a declaration, arguments, and the return values. Right. So we'll start with the decorators itself. So when we were creating the call method, we saw that it is basically used to bypass the function creation. Using the call method, we can just bypass the function creation. We don't have to create another function for a specific operation. Okay. So decorators are something that can be used to extend a functionality of the function that is already existing. Okay. So if we have a predefined function, a user defined function in our program, if we want to extend the functionality of that function without actually modifying the definition. Okay. Remember that without actually modifying the definition of the function. If we want to extend some functionality for our use, we can use the call method to create a decorator. Okay. That will be the decorator to this class. We'll associate that decorator to the class using the operator, and we'll use the call function to create the decorator. Okay, so we'll see how to do it. First of all, we'll look at what are the use of decorators. I already told you that we have a principle called as DRY. It's called don't repeat yourself. It is basically because when you have already written a definition for a function for some other class, if we want to use the same function for our class with some extended functionalities, we might not want to create the function again itself. We can call something called as decorators so that we can extend the functionality and use it in our program based on that. Okay, we can add some code before calling that function, or we can add some code after calling that function. So that will be required to bypass the again the function creation. Okay, so we'll see how to do it. First of all, we'll look at the declaration itself. Okay, so let me just erase this all. We don't require any arguments, so I am not taking a and b, which I took in the last section. I also don't want any arguments to be initialized. I'll remove all this and I'll remove this. So in this, I will just want to have a function so that we can extend the functionality to it too. Okay, so I'll write here a function. This is a function name that will be supplied it by the object. Okay, so what we'll say, we'll assign the value because it is an initiator, it's a constructor init function. We'll assign the value and we'll do it by using self. Okay, so self dot function. Now this function that I have written just now is a member of the class. Okay, it associated to the class. So don't get confused with the argument. This argument we will assign to this function. Okay, so the argument of function that we have got using the user, we have assigned it to the function variable that is associated to class. We don't have to define this function because it is already declared with the class. Okay, like the constructor itself. So that is all we have to do here. What we can do is create a function. Okay, we have to extend the functionality of a function. So first we have to create a function, and of whose functionality will increase. Okay, so using a def keyword, easily creating a function. This function should be same as this argument because it will be associated. Next, we don't want to supply any arguments right now. We'll see how to do it later on. First of all, we want to create a function. So I'll just say that I want to create a function that prints hello to me. Okay, so it prints hello to me. Now what will I do? I'll create an object for this. Okay, if I create an object, I will use that object to call the function call. Okay, but we don't want to do this. We want to create a decorator for this. Okay, so that whenever we call this function itself, it will call the extended functionality also. Okay, so we don't require any of the objects here. It will bypass the object creation as well. Okay, what we'll do, first we will associate this function to this class. How to do it? We'll use the operator. So using operator and the class name, that is my class, using this, the function is now associated to the class itself. Okay, So this function is now working as a decorator. Now if I call this function, because it is having no arguments, I can just call it by using this. If I call this function, what will happen? First let's execute it, and I will have to change this call function. For this function there are no arguments required and I'll say nothing but just call this function. How to call this function? This function is associated to the class, so it will be accessed using self. What is its name? Its name is function. And what is it? It's a function, so we'll use parenthesis. Okay, so let's try to run this program and see what happens, and then later on I'll explain what is the flow of the program. Okay, so let's execute it. It says hello to me, right? The output is hello. Now let's see what is happening over here. I created a class. It has it has a constructor function which takes function as an argument, which we have declared outside of the class using decorator. Okay, I have created a call function taking no arguments, and what it is doing, it is calling the function itself and nothing else. Okay, so execution starts here, the interpretation starts here, it goes to constructor, it goes to call, nothing happens. It goes to the decorator, nothing happens. As soon as the function is called in the line number 83, you can see over here, as soon as the function is called, the execution does not go to this function definition. Okay, does not go to this function definition. The execution goes to the call function. Okay, this execution does not go to this function because it is a decorator to the class. So this is bypassing the function calling. It is going to the call function. The call function is calling the function definition. Now the print hello statement is executed, and as we have specified no other execution statements, it ends the execution right there. Okay, so this is how you declare a decorator, okay, using the operator, a function, and you can supply the arguments in a constructor over here. Okay, that is how you do it. Next, let's move on to the arguments also. We'll see how to pass some arguments to the function, because in this function we saw that there are no arguments. How to supply arguments and where to keep these arguments. Okay, so let's see about the arguments. Okay, so let's say that I want to pick a message to a user. Okay, I want to display a message to the user, and using the name and message, two things. I'll use two strings, name and message, and I want to supply these two things over in the call function, and we'll see where to supply those arguments. Okay, so let's say I want to supply a name and a message. First of all, in the definition we will have to include two arguments. First will be name and second will be message, right? We have a name and message. We want to print something, so we'll use print statement. What we'll want to do, we want to print string, two strings back to back. So I'll say that this first curly brace is for first string, and this second curly brace with a space separated by a comma is for the second string. Okay, using dot format that you have already studied in Python programming. I hope that you have already studied about format and using double strings or more than one string in a single print statement. We'll be using that. Okay, so using this format, I'll say that I will supply the first as name and the second one as message, right? The first will be name, the second will be message. Okay, the spelling is mistake. Yeah, so I've created a function that prints two things. Now I have to supply some values over here. Let's say the name I want to give is Abhay, and the message I want to give is how are you, right? So I want to print both these statements using this function. But I already told you that after calling this function, the execution doesn't go to this line, right? So if we try to run it right now, it should give me an error if I am right that execution is going to call function, because in call we are not accepting any arguments right now, but in this function definition we are accepting the arguments. So if I am right that it is not going over line number 80 def function, it should raise an error right now. Let's see. Yes, it is raising an error. It says that 3 takes one positional argument but 3 were given. So it concludes that this function calling goes to the call function, right? So we have to accept some arguments over here. in call, if you are supplying these two strings, you can say that you can accept the arguments like this, right? You can accept these arguments like this and supply it over here. But what I do usually is I will not write multiple arguments for multiple these things, right? I will say asterisk args. What is this asterisk args? It will take any number of arguments that can be integer, string, or any kind of value, and create a list of all those things, right? Create a list of all those arguments and name that list as args, right? So I don't have to write multiple arguments. Suppose right now here are two arguments. If I want to give multiple arguments, I will have to write multiple arguments here as well. So I will write just asterisk args, a continuous list of multiple single digit values, single oriented values, right? So, and optionally I will write kwargs. You must have studied about this also in Python. Keyword arguments are the arguments that are already the list. Okay, so suppose I want to supply multiple list also, like a list of fruits and a list of vegetables, then we can accept all those lists as a double list in double asterisk keyword args. Okay, so this is optional in our case, but usually as a standard I am writing it, right? And this is the required argument. Both of these, Abhay and how are you, will be accepted in asterisk args and not in both. Okay, this asterisk args will serve as both Abhay and how are you, right? So I'll supply the same arguments here as well. Remember that in our case, as double asterisk keyword args is optional. You can also omit it, but as a method of standard, I am writing it. Okay, so we are calling this function now with two arguments. Let's see, run it, if it gives us a value right here. Yeah, as you can see, I have received the value Abhay comma how are you. So it concludes that we have called the decorator using the call function associated to the class, right? This is how you can execute some arguments. You can give any number of arguments, as I already told you, in args, or you can give the list arguments in kwargs, right? Next we move on to the return statements. So return statement are something that we can return a value that we have computed in the call function, right? So let us try to return some value now. I'll say that I will take a number from the user and try to return its square, right? Suppose the user has given me the number 3. I will like to return 3 cross 3, that is 9, right? So let us change our function according to that. You can pause this video and take a screenshot or write it down so that you remember all these. I'll just make it a comment and issue a new print statement so that I don't have to yeah, so from the next line I don't have to remove this print statement. You can always copy, you can always write it over it. I will issue a new number, right? So I'll say number is, and I'll issue a n, right? So it will give me the number what I want to say, and then I will return, just return number. This n I haven't defined, so I have to take an argument over here as n, right? This n will be supplied by the user. What I will do, I will print that the number is n and I will return its square using this return statement. Yeah, pretty simple one. I hope you can understand it from right here. I don't need to explain it much. So the user will supply the number also. Okay, so we'll say that function of we'll say 10, right? Okay, so that's how we do it, and we'll issue a print statement also before it so that you know that we are printing the square. Square is, right, and we'll call the function. Now in the call we have to modify it. Okay, so if we have to compute a result, we'll do it by using another variable. We'll say that we want to store it in a result variable. What will be the value of this variable? We'll call the function, because this function itself is returning the value. This function should use this square to supply the value to the function definition, right? So using self dot function, we can call this function. What we'll say, we'll supply the arguments using the same. You can also include just one argument over here instead of args and quarks, but as a standard of definition, I am using both of these, double asterisk quarks, right? So the result of this statement, of this function, will be stored in result. At the end, we want to return this. As I've already told you, the definition called first is of call and not the function. So if we have to return something, we have to return it in call as well. So return result, right? So as it is returning the result, we want to print it. So I'll say print, and inside it I will call this function. So anything that will be returned by this function, that is the call, will be printed. So result will be printed, right? So I will expect that I will get a value 100 from here. Let's see what happens, and then I'll tell you what is the flow of the program also. Okay, let's try to run it. Okay, the first, okay, we are getting the output as correct, but we haven't modified it correctly. Number is 10 we are getting. Square is printing before the number is statement. Okay, let's see why it is like that. Okay, so we have printed the square is as an individual statement, while the function definition is being executed when the function is called, right? So we don't want to print it here. We will want to print it just before printing the result, right? So we want to print it here. Now if we execute it, and we are getting the right answer now. Number is 10, then square is 100. So let me tell you the flow of the program here. Let me just close this one. Okay, so in the class we have a constructor and a call function. We have a decorator associated to the class. As soon as we call this function, that is an individual statement, we say print function 10. This line of code takes the execution to the call function, right? This does not take the execution to the decorator, but it takes to the call. Okay, so nextly, the result variable is used to store the value of the function. We are supplying the argument 10 to the function definition, which prints the number is 10 and return the n cross n. Now n cross n is 100. It is returned back in the call function. It prints square is that we have seen and return the result. As soon as the result is returned, we will print the value. That is why we are getting the 100 value here. Okay, that is how you return the values from the decorators. Now to justify the real use of decorators, we must enhance the value somehow. In here you can see I have enhanced the definition. This definition of function is just printing number is and returning the square. Its functionality is being extended by the call using this print statement. Okay, so if we want to extend the functionality, like here, we can use decorators. For example, I will like to say that executing, and as soon as the result is ready, we are printing the result. Okay, so if we want to say, like, first of all we are trying to execute it, then we have number is 10 and then this is square. The real function just prints that the number is n and returns the square, while we have modified the definition without actually modifying it using the call function. That is how we use decorators. Okay,